This is STA 381, Chapter 6, Section 4, box plots. All right, so we're going to look at another visual representation for quantitative data. Last time we looked at the histogram and talked about some aspects with that. Remember socks? This time we're going to be looking at box plots. They're also called box and whisker plots, but they're not called that so often anymore. All right, so we're going to take a look at a box plot here. So notice that it's a graphical display showing center, spread, shape, and outliers. It's a great representation. I really like box plots. The only thing you want to be careful of is that you do lose some information about the rest of the distribution because you're not plotting every point like you would be even within a histogram or something like a dot plot. So just be aware that they're a very useful tool, but you tend to lose a little bit of your information. Okay, so what it does is it displays what we call the 5-number summary. 5-number summary are made up of your minimum value, Q1, median, Q3, and the maximum value. All right, so just as a quick review, you know what the min and the max are. Q1 is your first quartile. But let's start with the median. The median is also your 50th percentile. And so that means Q1 is your 25th percentile and Q3 is your 75th percentile. Now, software will find these for you. You'll find them very easily in RStudio, Excel, etc. There are different ways to calculate those 3 middle values, so just keep that in mind that if you want, one way to calculate them is, so let's say you have a set of data, and I'm just going to make it super simple. So here's my set of data. The median is the middle, so that's your median, and I think they have it as x tilde. And so one way to calculate Q1 is to exclude the median, look at everything below it, and then find the median of the lower set of numbers, and so that would be Q1. And then likewise do the same for Q3. But I will tell you that RStudio, and I know some other software, actually do have some slightly different calculations, and so sometimes you'll get values, say you might get 2.3 here or 5.9, and you may be wondering, well, why are those values different? And just realize that there are different ways for computing those, and they're always going to be really close, but sometimes they won't be exactly the same. Okay, so getting to the box plot. What we have here is, first of all, we have the box. And so notice that the first quartile, or Q1, forms the lower end of the box. The second quartile, or the median, forms this middle line. And the third quartile, or Q3, forms the upper end of the box. These vertical lines that come out from there, those are called our whiskers, by the way. And that's why sometimes it's called a box and whisker plot. So the whiskers will go to one of 2 spots. Here, it's going to the smallest data point within the 1.5 interquartile range from the first quartile. Well, let's talk about what that interquartile range is for a second. The interquartile range is equal to Q3 minus Q1. That's what our interquartile range is. And so if you remember from an earlier lecture, I said that that is another measure of spread, and it's the one that we would use if we knew we had skewed data or some outliers because it basically excludes those values. So the whisker extends to the smallest data point within there. So it goes to this point right here. So you take Q1 minus 1.5 times the IQR, and the smallest data point that's within that range is where that goes to. And then every point that lies without it, or without it, outside of it, are designated with dots or stars or something like that, and those are our potential outliers. Same with with the other whisker. It's going to be Q3 plus 1.5 times the interquartile range, and it extends to the largest point within there. So wherever that largest point was, because notice that if you just go all the way to the end, it's a little bit beyond. And then again, we have outlier 1, 2, and 3. Now, I do want to mention a couple things that different software approach this slightly differently. Some of them go all the way to the end of 1.5, the 1.5 IQR plus or minus Q1. And some of them do what this says here in this textbook. So you just need to pay attention. They'll be in similar spots, but just pay attention to what is going on with that particular set of data. And generally, the documentation will tell you. Okay, so just looking at an example here. So we have a box plot of compressive strength of 80 aluminum lithium alloy specimens. So notice that we have our median, that's our median, is 161.5. We have 181, that's Q3, 143.5, that's Q1. So our interquartile range is the 181 minus the 143.5. And then our whisker goes to that point right here where you take Q3 plus the 1.5 times the IQR. So you would take 181 plus 1.5 times the IQR, which was 181 minus 143.5. And the largest data point that's within that, that's where it goes. And that was at 237. Same thing over here. We get the 143.5 minus 1.5 times the IQR. And then the smallest data point, which was 97, lies there. So we have a couple outliers, and so that's kind of the beauty of the box plot, is that we get to get this idea about how the data spread, because notice the data here looks fairly symmetric. We see a slightly longer whisker here on top than on the bottom, but overall it's pretty symmetric. But we do have a couple outliers that we need to go back and investigate. Why do we have a value of 245? Is that really an unusual value? Is there something wrong there? Was there a data entry problem? It gives us an opportunity to go and take a look closer at our data and investigate what's going on. And so that's one of the beauties of the box and whisker plot. So usually using these in conjunction with histograms are really quite helpful for just some quick and easy data analysis. Now I do want to come back just really quick before we close out and write a really good mantra on the board, and that is plot your data. Start with plotting your data. Do the best. Figure out what kind of data you have, quantitative, categorical, and then plot it, because getting a visual representation of what's going on gives you a whole lot more information than just the numerical summaries at times. Because the numerical summaries gave us, the mean, the median, and you could get the 5-number summary out, but really being able to plot the data, seeing the outliers, seeing the shape, seeing the spread. We're just visual people, and we need to see our data displayed for us in front of us to get some ideas. So we don't want to rely totally on that, but that is the number one place to start with data analysis, is to start with plotting your data. All right, that's it for the lecture.